My name is Nabeel Vandayar. I'm fourth year information engineering student at Wits.
I am Timothy McBride. I am also a fourth year information engineering student at Wits.
Cool, thanks guys. So just tell us a bit about your project. What was your project?
Okay, so our project was to design and build a hand gesture recognition software that would allow a user to control a computer using only the webcam. And the main focus of the design, or the main constraint of the design, was that it had to be low cost by all means. So from the webcam, instead of a HD camera, and you not using a laptop's GPU, just everything being able to run on a regular laptop.
Okay. What were you able to do with the MathWorks tools, and how did they make a difference to your project?
The core component of the entire system is the machine learning model, or the neural network. And I did experiment with a few other platforms, from Python to using TensorFlow and what's the other one?
PyTorch.
And, TensorFlow and PyTorch. And the startup time, or the learning curve for those, was so high, and the support for those was really not really that good. So the main thing that we used in MATLAB was the neural network toolbox, because firstly the support was very good, and the examples that were provided got us about 50% of the way there, and then we just had to modify it a little bit, change the code here and there just to optimize it a bit. Yeah.
So what would you say your biggest technical pain was then, and how did the MathWorks tools help you?
I suppose it was actually the getting the system to run in effective time as well. That was probably one of the hardest, well, the biggest technical difficulties.
Yeah.
Whereas with MATLAB, the fact that it did handle a lot of the multiplication, or the data intensive side of things.
Just to go into the details just a little bit more, one of the main things that we're doing, the main function that MATLAB provided with regards to the user interface, was allowing us access to the webcam, which was quite simple, but also storing that information in a database or a data store, and then when you actually use that information to build a model, it does automatic, what is the word? It's like adjustments and stuff. So in the machine learning model, you want the images to be maybe shifted a little bit left, right, up and down to account for variability. And MATLAB does that very, very easily. And that improved the accuracy of the overall model. And just having that tool available to us reduced development time drastically.
What was the most valuable thing you guys learned while building this project?
I suppose it would be to accept that you can get negative results, and that some systems that you develop are not always going to be, or are not always going to work, and you may need to discard work that you've done over a period of time for better solutions or better models, you could say.
I think that the choice of platform up front is a really important decision to make, and it affects the path that you take going forward. You have to choose something that's on your level and that will allow you to develop and actually produce a solution. So we know from our experiments that MATLAB is very good for getting you off the ground, but from our research we found that other platforms might be better for optimization, but again, that requires that learning curve and all of that to be taken into consideration. So the choice of platform is very important. Yeah.
So onto platform, what was your perception of MATLAB before and after your project?
We had a very, very good perception of MATLAB. I mean, we've been using it ever since first year. There was that familiarity of it. And even though MATLAB does allow you to do like really complex technical software builds. The user interface and the support for it, it really makes everything a lot more accessible, and I guess the community behind it also, it just makes developing more interactive, I would say, rather than just you trying to find a solution. You just
I mean, I would say the same for me. It's been very familiar, and I've always kind of thought about how you can use it.
Yeah.
And most projects, I tend to use it over other platforms.
I'm just, while we carry on, I'm just going to run this program again. But while we're talking, I'm going to have to actually perform certain actions to train the model in real time.
That'll be great. Awesome.
So I'll still respond to you, but I'll be doing funny hand signals.
Okay, cool. Where do you think this kind of technology could be used in industry or commercially?
So, I mean, I can basically answer that. This kind of technology is already being used in some aspects. A lot of it is related to like the Kinect and some of your other 3D depth sensors and that sort of thing. The main future uses for it would be in medical practices. It allows possibly surgeons or doctors to manipulate a computer and view various things without actually using it or without touching anything. It can also be used for robotics and control of robotics in dangerous environments, or environments where your standard systems aren't really friendly. This could be underwater or in space or some things like that. The main benefit of it is that it is a more natural form of communication. It is more relatable to what human-to-human communication is like. So that is why this is kind of worth research.
One of the things we found in our research was that the system is, like you said, currently being used. Vandayar is developing a system for controlling the dashboard inside your car, just without having to press any buttons and not having to like distract yourself from the road situation. So if you want to change volume, you'd be driving along and you just up, down, next song, back. And I think that has actual practical applications in like, saving people's lives and preventing accidents.
That's really awesome. So you guys seem pretty passionate about this. Is this something you'd want to try and carry on at your next jobs, or?
Maybe not at my next.
On the side?
Maybe not at my next job, but definitely on the side. I think that AI. Right now we focus on the software, but I think AI hardware is kind of like where the industry is going. Creating artificial neural network endpoints that can gather and process information and provide these sort of automation products, I guess. I think that's definitely the direction the industry is going. And we have seen that in research with TensorFlow doing, I think it's called, edge computing, but using artificial neural networks.
It's really cool.
So, the one thing that I did kind of remember is that some of the main applications for this would be in video games, and not necessarily in the sense of like the Kinect, and that it would maybe be more for disabled kids or for educational purposes as well. You can also use it in some medical aspects to help people with disabilities and provide them with a system that they can actually control.
Okay, so right now you're seeing the neural network that I spoke about earlier being trained with the images that you saw me, you saw me performing. So I don't know if you'll be able to see it, but that actual entire process took about 2 minutes from the time I started doing the gestures to now when the system has already been trained. If I just go back to that, I guess you'll see me on screen there, but if I just go back to the training process, you'll see that the system is being trained over many different iterations. I think the total is about 35, and the accuracy that you see in that blue line over there is increasing on almost every iteration. And there's another statistical measure called the loss, which is related to the the performance of the neural network itself to distinguish one image from another. So in this application, it's distinguishing whether my hand is here or there or wherever. And initially, it's not really very good. It has a high loss, which means that it's not making the right predictions. But over time, as we train the model more and more, you'll see that the loss decreases, the accuracy increases, and if you speak to someone in the industry, they'll say that this model is overfitted, and it is overfitted, which is generally not a good characteristic of neural network applications. But for this specific application, since you're trying to determine how a specific user, so the system would run for my laptop specifically, you try to identify that specific user's gestures. So overfitting a model to an individual is like having a suit tailored for you yourself. It makes sense to do that. So the entire training process took about 2 minutes or so. I can close that now. And now what you're seeing now is what the webcam is seeing. And we've created this grid, which is actually based off the golden ratio that we find in nature. And we found that using the golden ratio to split up what the camera sees, creating these regions, it actually helps to separate the regions that your hand will be in when you naturally perform a gesture. So when you go from the center, which is just a natural position here, when you swipe to that side, it's actually you're only crossing one barrier to go from there to there. Whereas if we use the bigger grid, you'd have a bigger error because you'd be crossing many lines and stuff. So that was just a design decision.
So, do you want to just show how it works quickly?
Okay. One of the things we showed on Open Day was being able to control a video in real time. Now, other applications that we found, people don't actually control things in real time, but we don't think that that's something a user would want. So, for example, the Daily Show. That's a nice example. I haven't forgot the controls, but I think you can increase volume. First, I think my volume is off, first of all. I'm just going to put this on the side so I can actually see what I'm doing. Okay. And ads, get rid of ads. So you on the right hand side of the screen, you'll see what I'm doing, and the left hand side is obviously how the system responds. So by putting my left hand up here, I'm specifying that I want to have access to control the arrow keys on my keyboard. And if I do this, it should increase the volume a little bit.
But we're dealing with just the YouTube volume and not the actual computer volume.
And if I bring my hand down, it should make it a little bit softer. Sorry. There we go. It's going softer, but it's going very slow. Okay.
That's really amazing. Wow.
And if I, let's just say, let's make it louder again, go faster this time. And let's say I want to rewind because I missed that joke, I can just do that. Which is cool. And other things you won't see, because that's just one feature. The other things you can do is scroll up and down if you're reading a document. You can increase and decrease the screen brightness. You can turn the monitor off completely if you want to walk away for a second and come back. It is customizable because the initial motivation for this project was to create a system that my dad could use. My dad was in an accident a few years ago, so he doesn't really have the fine motor skills. He is able to move his mouse around, but he can't really type, and he's not really that proficient with the computer to begin with. So by creating a system where when you perform a gesture that he knows how to perform, and you map that to some kind of process, whether it's opening an email thing for him to write, or whatever it is, it just makes the whole experience of using a laptop a lot better for people. So I mean, it is a nice tool right now for everyday users, for like regular people, but people with disabilities, I think it is definitely an improvement to the normal user experience.